This is a tetrahedral resistor shown in 3D. To calculate the net resistance of this system, press the top vertex down to the same plane. Now observe the top view and notice the plane of symmetry. All points on this plane have the same potential, which is why no current flows through the vertical resistor. Quick question. If we swap the lower resistor and the battery, would anything change? Let us know in the comment box. So remove this resistor and we can easily find the net resistance. Finally, the net resistance will be R by 2. Now let's move on to calculating the net resistance for a pentahedral resistor. By pressing the vertex down to the plane, we get the system shown. Here too, the plane of symmetry is vertical and perpendicular to the current flow, making these 3 points equipotential. We can separate this junction, since connecting these points with a wire wouldn't cause any current to flow. Finally, the net resistance will be 8R by 15. Suppose the battery was connected diagonally, the plane of symmetry changes, causing a different set of 3 points to share the same potential. This creates a bridge-like structure, allowing us to remove some resistors and calculate the net resistance more easily, where the net resistance would be 2R by 3. Next, let's consider a cube. The plane of symmetry runs along this diagonal, making 2 pairs of points, shown in orange and blue, to have the same potential. On joining these points together, the circuit would look like this, simplifying the calculation of net resistance. Finally, the net resistance will be 7R by 12. If we connect the battery to the face diagonals, the plane of symmetry shifts along this diagonal, where the orange points have the same potential, meaning no current flows through certain resistors. Removing them simplifies the net resistance calculation, where the net resistance will be 3R by 4. Finally, if we connect the battery along the body diagonal, the symmetry aligns such that the same current enters 3 resistors and exits through the other 3. Where the orange and blue points have the same potential as shown in 3D. Joining them will result in a circuit as shown, and so the net resistance will be 5R by 6.